It was good? Anyone have any issues with it? Anyone want to go over example 1 on page 64? No? Okay, let's just remind ourselves of how we go about these questions. Will a precipitate form? Yes? If I give you a 0.2 and a 0.2, that's easy. You just look it up on the solubility table. If I say mix equal volumes of 0.2 and 0.2. But with these ones, you have to identify the precipitate. You will be given 2 compounds. This is page 64, actually. Did I press record? Was I clever enough to do that? I did. Okay, good. Go. So you'll be given 2 compounds. And you need to identify the precipitate. Now, should you wish to write the precipitation equation, that's fine, but it is not required. You can just identify it, okay? So you can write the PE if it helps you, but it's not required. Okay, and at that point then, once you've got your precipitate, you would then write the solubility equilibrium equation. So you're writing the solubility equilibrium equation for almost all of our calculation problems. We wrote it for when we're given solubility, we asked to find KSP. We had to write our C. We would then write our KSP. In this case, we're going to write our Q, and we plug our initial concentrations in there. You need to calculate the molar concentration of the ions using whichever dilution calculation, because you are mixing 2 compounds. So this is a mix and match. So you will not have a 2-to-1 ratio or a 1-to-1 ratio or whatever it is. And then finally, you plug your concentrations into Q and solve, and then you compare it. If Q is too small, if Q is less than KSP, too small, then the ion concentrations will be too low. So no precipitate will form. If Q is greater than KSP, we are now on page 65. No, still on 64. What is wrong with me? Now we are too big. That means too much ions. Ion concentration is too high, so a precipitate will form. The last one, we didn't talk about this last day, but if Q just equals KSP, a solution is perfectly full of ions. It's sitting on that knife's edge ready to precipitate, but it won't actually precipitate. It's just barely saturated. No precipitate will form. How likely is it that we're going to be in that sort of a situation? Very unlikely. You would have to, really finesse it to make that happen. Okay, so we felt good about example 1, or we didn't do it, one or the other. Okay, let's do example 2. Do you need me to work through it with you, or can you do it yourself? Can you do it yourself? You'll figure it out? Excellent, excellent. You do have the steps right over here if you need them. Okay. Walk slow, walk faster. Is awake. Stretch your chin is awake. Turn awake. Hold, hold, everything's so true. Oh, so it's awake. Sample change. You know where it started? No, it's not. We got it. You understood that you're asking the question. Something is big stuff. So it has to be. Okay, so here's the deal. If you're actually a precipitate form, technically, yes, you should be able to check it. If I give you an example, we have to assume that there's the other which is solved with other things, so you can see the other one. It's maybe not the best question in the world, maybe one that actually doesn't change that for next time, but yeah, yeah. Oh. This sort of situation is where the noon formula is really nice because you don't have to rearrange anything. You just chuck it in there. That's our old concentration, old volume over new volume. But if you're happier with the M1V1, that's great too.
How does AG to the AG
Hmm?
How does concentration of silver the silver nitrogen?
Because it's 1-to-1. Yeah. Feel free to write that out if that helps you. Yeah. Did you guys get those concentrations? Oh, I forgot something. How comfortable do you guys feel with this? Because there are other ways of showing that work. If you're like, I don't know why it's 2 times and not a half. Because I know that some people get like messed up in that. Yeah. So if you're like, I don't get it, fear not. You can do it the following way. There's a couple of different ways to do it. You can say, I've got CaIO3 2. Sorry, that should be a one-way arrow because it's completely soluble. There we go. And that gives us Ca2 plus aqueous plus IO3 minus aqueous, and we have a coefficient of 2. So if our concentration of CaIO3 is 1.0 times 10 to the negative 4, then our concentration of IO3 minus is going to be 2 times 1.0 times 10 to the negative 4. there's a third way to do it, but I've kind of run myself out of room. You could do concentration of iO3 minus is equal to 1 times 10 to the negative 4 moles of CaIO3 2 per liter times 2 moles of iO3 minus per 1 mole of CaIO3 2. No matter which of those methods we use, we will get 2 times 10 to the negative 4 molar. And I actually skipped my Q expression. So I'm going to do my Q expression down here. Sometimes I do the ion concentrations first because it kind of makes more sense, and then I do the Q later. Just do whatever makes sense in your brain. As long as you do both ion concentrations and Q. Q is equal to silver times iO3 minus. And then we have our silver is 5 times 10 to the minus 5. Times iodate, which is 2 times 10 to the minus 4. And that's 1 times 10 to the negative 8. There should have been lots of room for this question, but I just got carried away showing different methods of getting your iO3 concentration. Maybe I should label them. Method 1 to find concentration of iO3 minus. This is method 2, and this is method 3. Only pick one, don't do them all, because that's crazy. Yes? I'm only showing them to you all in case you like one better than the other, or they make more sense one way or the other. What do we do with our Q value now? We compare Q and KSP. I don't know why I left so much room in those blanks there, but that's okay. Oh, I think I meant to put values in there. So Q, what is our KSP? Hopefully we have one in our data booklet. Silver iodate, 3.2 times 10 to the minus 8. So this is less than, whoa, where'd you go? Hiya. There we go. Less than KSP, 3.2 times 10 to the minus 8. And therefore, what happens? Therefore, no precipitate forms. Would you like to do one more example, or do you feel like we're done with this? One more? Okay. What's that?
Like your final answer for Q.
My final answer for Q is in pink. There.
What is IMP stand for?
IMP what?
Like plug in. Oh, plug in.
Plug into Q, plug the values into Q. All right, give example 3 a try. Like, what is happening? There you go. Sorry. Equilibrium equation. Precipitation equation goes to one. Yeah, yeah. So if you were writing the formation of this precipitation, yeah, yeah.
Otherwise, chemistry is kind of like math. Like it's how I do it because like math, like I just draw everything.
Yeah, pretty much. Okay, so you get to use one of methods to find the, because they're mixing with each other, they're trying to do methods. So what are you doing? Say, concentrate, concentration, same pattern, but trace it off. So you can think I'm doing 50 milliliters. So I'm going to hold the final 70 milliliters. And I can ignore whatever because it doesn't matter if there's other stuff. Oh, so you're adding. No, there's a concentration. you guys planning too. Yes. You got it, I guess.
Yeah. Yeah. You write more decimals.
I usually do. It probably doesn't matter for this case because we're doing a comparison and we're not going to any significant figures or giving a numerical answer. We're saying yes or no, but just out of habit, it's usually what I do. Yes.
I forgot to swear.
Oh, I totally forgot to square it. Thank you. Yep. Let chloride.
No.
Oh my God, what is wrong with me? Okay, hang on. 0.07143. Is it in there in the queue?
I think it's 0.011.
Is it? Oh, gracious. 0.04 times 20 divided by 70 equals, yeah, no, yes. Oh, good gracious. 0, 0. All right, all right, all right, all right. Hold on. 0.07143 times 0.01143 squared equals times 10 to the minus 6. Okay. Okay, minus 6. Oh, I'm sad. I was hoping we would get a precipitate for once, but that's okay. Okay. Whew. I think I need to change one of these examples so we get a precipitate in one of them, but yeah. If I did 0.4 molar, that would work. Okay. So how are we feeling about this type of, that's just for me. That's just for me. How are we feeling about this type of problem? Is all right? Yeah. Okay. So I don't know what happened last day. For some reason I skipped. Yes, sorry. How do I know what KSP is? It's in here on page 5, I think. Yep, page 5. Good question. Either it will be given to you in the question or it needs to be findable in the on page 5 of the data booklet. Okay. So like I said, for whatever reason, my brain skipped over 3.3b last time. So we're going to go back and do that one today. Which is on page. Did we do it?
We did.
I'm so confused.
Oh, we did do it. Oh, we didn't finish. Oh, we did finish. Never mind.
Oh, okay.
Yeah,
Okay. Oh, okay. Never mind. We're good. We're good. And now we're going to do 3.3D, finding solubility from KSP. That is on page 67. And before we start, everybody define KSP, or sorry, not KSP. Please define solubility for your neighbor. Tell them what is the definition of solubility.
substance that can be dissolved. Even metabolic. Yeah.
What is solubility? Solubility is the maximum amount of solute. We could use the word solute instead of dissolved substance, because that's what that means. The maximum amount of solute that is dissolved, that can be dissolved in a given volume. So what is a unit of solubility? Moles per liter. Is there anything else we could use for units of solubility? Yeah, what else could we do? We could do moles per milliliter. What else could we do? We could do millimoles per liter. We could do, what could we use instead of moles? We could use grams. We could do grams per milliliter or grams per liter. Just a little reminder there of all your different possible units, but we always focus on this one. All right, so we are finding solubility. That means we are finding the concentration. Yes? And we are finding concentration of the salt. AB, solid, or A2B or whatever. So we are finding the concentration of the compound. There are a few things that you need to, this is fairly straightforward, but you need to follow these steps essentially because you get 0.5 marks for writing a let statement. Because the concentration of the compound is our unknown, and this is the solubility. Huh?
No,
Oh, I lost the L. It went away. I don't know. I must have erased it by accident. Let X be the molar solubility of A2B. And what that means is let X be the concentration of A2B max. Because solubility is the maximum concentration. And then, of course, because we're going to be dealing with a solubility equilibrium, we will write the solubility equilibrium equation. We need our ion concentrations. And in this case, our ion concentrations are going to be in terms of X because we don't know the concentration. So we can write just underneath. Why do I put this one in brackets? Because it's a solid. And then we have, if we have 2A, that's going to be 2X. If we have B, that's going to be X. We will write a KSP expression. And then we will plug in KSP and our X's. Where do we find the value? Find the value either in the question or data booklet. So we plug in our KSP, we plug in our X's, and then at that point, it's just algebra, solve for X. It's not a quadratic because there's no pluses and minuses. It's all just multiplying. So 4x squared times x equals 4x cubed, blah, 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 blah. And we end up getting x. And if you remember, in the past, we said let x be the solubility, right? Why would it be insignificant? You're good? Because it was in the past. Okay, so let X be the solubility. Therefore, X is the solubility. And so it is the concentration of A2B, which is 0.021 molar. And there we are. Bob's your uncle. So do you think you guys could do an example? Okay, all the steps are there for you.
I know, like, plus they have feedback.
Oh, let's grab you a table. There you go.
Oh, yeah, but like, I feel like like yeah, that's like, no, because it's per se, you act times X is X squared.
Oh, X squared. Yep, not 2X. Why did I write? Oh, yeah, that's correct.
That's 17. I wrote. I mean, like,
Did we get 9.2 times 10 to the minus 9? Yes.
What 9.2?
Uh-oh.
Oh, wait, Miss Brett.
Yeah.
I didn't get the 9.2.
You didn't get 9.2?
I got 9.0.
Oh. How did you do that?
No, you said 9.2.
8.5 times 10 to the negative 17 square root?
Yeah.
Oh. You've just run out of decimal places.
Wait, how do I get more?
Okay. So,
Is there a way to get more?
hopefully somewhere on here you have a mode that will do that. Hold on. It might be this little FD thing, but I'm not sure. So what I'm going to do is I'm simply going to multiply by 1,000. That's going to give me 3 more digits.
Okay.
Okay?
What are the chances that you find well, I know that was crazy. That's just saying.
I was looking for storage grids and not looking around myself.
What? Okay.
I don't think I'm gonna have
8.5.
I think you got the right answer.
Let's add to
You
that.
got the correct answer. I don't know.
Yeah,
Why.
8.5. Where's your times 10 to
Okay,
that?
I'll be like, my mom, and then you stop me. Oh.
No. Don't.
And
There. Okay. How do I clear it? Okay. Hold on. CE.
Oh.
8.5 times 10 to the negative 17. Oh, except I probably should just type root first, right? How do you root that?
Oh, well.
17. Okay, there's something wrong with this calculator, and I don't know what it is. Get a different calculator. Yeah.
I don't know what I'm
Okay. Try example 2. Example 2. Pardon me? You have to find moles per liter first, and then you'll convert it to grams at the end. Okay? Because your KSP works in moles per liter.
It's converted. Let's see if my calculator can. Oh, yeah, we state.
And you get KSP value.
Would it be 3x? It would be 3x.
Yes. 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 Yeah.
What is the PSBO? Where the hell is that the overhead wrong?
I watched episode 1 like you.
Oh,
yeah,
they want to go people's back. I love playing. What do you? Yeah, what's it X times 9x? No, I think what?
Yes.
And 3x. 3x. Where do you get 3x cubed from? No, that's not how it works. Oh, we have to write the len x. You know what? I forgot. No, I can feel it, but I need an extra like that. Oh, you know, 3x cubed. Yeah, 3x cubed is literally 9x cubed. No, 9x. What are you talking about? This is 9x.
Hey, you guys are
27x.
seriously lacking in some algebra skills here,
Oh,
or at least some of you are.
Oh my days. No, like, I'm like questioning. I'm like questioning.
It wasn't square.
I'm like questioning. So like, am I not taking grade 12 math? That is 5. No, 5.
Okay, so just to do some basic algebra here, if we have 3x cubed, that means you take your 3 and you cube it. So you have 3 cubed. Yes. What? Oh.
Right? You should be.
Hold on. 4.9 times 10 to the negative 17. Oh, that's iron 2. Yeah, 2.6 times 10 to the negative 39. Sorry. Oh my God. Okay. Yeah. Don't get the wrong KSP. 2.6 times 10 to the negative 39. Okay. Okay, but let's get back to the algebra. Because we have to cube the 3 and we have to cube the x, right? What is 3 cubed? 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. It pains me that this is like difficult, but anyway. So we're going to have x times 27x cubed. And if we have x times x cubed, that is x to the power of 4. So 27x to the 4th is equal to 2.6 times 10 to the negative 39. Now x to the 4th, you don't have to show all of this, but 2.6 times 10 to the negative 39 divided by 27 equals 9.6296 times 10 to the negative 41. X is equal to the 4th root of 9.6, I'm going to call it 63, times 10 to the negative 41. Does everybody know how to take a 4th root on their calculator? Yes? Okay. And I get 9.9 times 10 to the negative 11. Is that what you get? Did I do it wrong again?
I go 1.0 times 10 to the negative. Yeah, that's right.
That's right? Okay.
Which one? B or?
I'm right.
Oh. What?
Sorry.
No, wait, what did I do wrong?
I don't know. Did you get 9.26 times 10 to the negative 41?
No.
Well, take 2.6 times 10 to the negative 39 and divide by 27. At that point, you need to say, am I done? Am I done? No, because this would be molar, and we were asked for grams per liter. Ooh, I don't want to write the square brackets. Why don't I want to write the square brackets? Because we're not finding moles per liter. We already have moles per liter. Okay, so I'm just going to say we have 9.91 times 10 to the negative 11 moles of FeOH3 per liter times, and we need the molar mass. 16 times 3 plus 55.8. 106.8. And we get 1.05758 times 10 to the negative 8, which would then become 1.1 times 10 to the negative 8 grams per liter. Now, if you are doing a written response question, it would be expected for you to show all this work. Yes? But if you're doing multiple choice, you can just be like, okay, I know that X is the molar solubility, And I know that at least if I got an AB salt, if I got a 1-to-1 salt, KSP is equal to x squared, where x squared is the solubility. Where x is molar solubility. Probably worth memorizing that one. Probably worth memorizing this one. 4x cubed. I don't think it's worthwhile memorizing A3. I think you could just do that like through calculations through the algebra at the time. But I think the first two are well worth memorizing. You might have something where it's, ooh, an exciting one where you have A2B3, 2A plus 3B, and you would end up with 2x and 3x, and KSP would be 2x squared and 3x cubed, which would be 108x to the 5th. Woo. But would you bother memorizing that? No, because you'll just throw it in and get whatever you get, right? Yeah. All right. Hey. So you could do homework. Page 68. And page 68, all page 66, numbers 1 through 5. Page 59, number 246. In fact, let's not do 68 all. Let's do 68, number 1 and 3. There we go. And you could start working on that right now. And if you're like, that still sounds like too much, you could just do 1 and 3. You could do 1 and 3. And you could do 2 and 4. Yeah? But if you have it in you, you could do the third one as well. Okay, so yeah, you have to take the number first. So like 4. Yeah. You don't have to show all the work in between, I just showed that.
What unit is this?
Yep.